Okay. So good afternoon, all. Let me introduce myself. I'm Ravi Kumar Krishnamurthy. I'm a Java and as well as Python developer, and as well as I do provide training for companies. It's good to see you all here. Can we start, Vinod?
Hello. Yes,
can we start?
Yes.
Yeah. Fine. So in today's webinar, we'll be working with some of the important features being introduced from Java 8 release, and it is most what we call as a big leap in modernizing the language features. So in 2014, Java 8 was released, and it introduced a multitude of significant features. Mainly, it's pointing to modernize the language and enhancing its capabilities by leveraging these features. Okay, particularly like what we call as a functional programming and parallel processing. Okay. So many of you would have been using Java programming language, maybe in your project or in your while learning the Java programming language and all. But this feature, starting from that is from Java release 8, it gives immense you know um, these with the help of functional programming and what we call making use of a lambda expression, stream API and all. Okay, so it gives the developer in optimizing the code while implementing these features. Okay, so what we're going to work here is we're going to discuss about what is imperative programming and declarative programming. What's the difference in this? What were the limitations still from before Java 8? Okay, well, mainly with the interfaces. Okay, what is functional programming? Then in functional programming, we want to work with how do we create, why do we require functional programming? How do we define or overcome the barrier of what we were facing in before Java 8, that is from 1 to 7, and lambda expressions. How do we make use of a double colon operator? Or we also call them as uh, a shortcut way of making use of these calling the methods and constructor reference and all. And also, most importantly, if you've been using Java 8 when you are working with developing any kind of Java application, it could be on backend side using Spring or Spring Boot and all. Making use of this Stream API it gives a lot of a concise way of coding. Okay. In this, we'll get into what is Stream API, what are uh, what you call as with intermediate operators and as well as terminal operators. And also, we'll work with by Java 8. It has come up with these supplier, consumer, functional interfaces, predicate, and all, and also date and time. Okay, so this is the basic an agenda of the for this webinar. Okay, am I clear? Okay, so let's understand first what is imperative programming language. It's a programming paradigm that uses statements to change the program state. Okay, it mainly focuses on how to perform the task by explicitly specifying the number of steps to achieve that particular outcome. Okay, So what actually it contains? So we'll be having on state variable can be modified, okay, and the program state can also can evolve over time as we make changes to that variable. Then we'll be using control structure. For example, making use of a for loop or a while loop, conditional statements, and any other controls flow statements, and also mutability. So both data structure and variables are typically mutable. That means it can be changed. Okay. So it mainly focus on how to perform the task by explicitly specifying the steps. That is what imperative programming means. Okay. For example, I want to show with one example with imperative programming. See, in my class imperative example, I create an array list object, and I've been assigning it to my list interface, which is of integer type. It takes a generic of a type of integer. Now using my for loop, okay, I want to add these numbers to my array list. Okay, so we have explicitly adding these numbers ranging from 1 to 10, okay, by calling add function from the list. So here we create, I'm going to modify this number. This is one way, it's a very variable of type list, right? And if I want to make any changes, now I want to get only filter the even numbers. After adding these elements and these numbers to my array list object, I want to filter even numbers. So for that, I'll make use of, again, I'll create another array list object. Okay, I'll assign it to another list object reference. Now I'll use a for loop. Okay, for this number which is being stored in numbers, okay, it has to iterate. Now I have a condition here. If modulus of 2, if it is equal to 0, then add this number to my new array list object. Okay, so we have to focus on how we're going to implement the logic for these things. Okay, we are going to make use of each, like with making use of a conditional statements for iterating with these elements. We're going to make use of for loops. Okay, then after that, I'm going to print all the even numbers. So here, we make use of explicitly with the adding, filtering or printing. We have to explicitly implement these things. Okay, this is what happens in typical imperative programming. It mainly focuses on how we're going to perform the task by explicitly specifying these steps. Okay, this is what we've been using. Now, what is functional programming means? So in functional programming, it's a paradigm, okay, that allows the programming using through expressions, okay, or declaring through functions. Okay, it treats computation as the evaluation of a mathematical expression or a function, and most importantly, it avoids changing the state and the mutability of the data. That means it mainly emphasizes on, instead of it, what to solve rather than how to solve it. Okay. So there are so many advantages with the functional programming. One is that is data structure are immutable. Once it is being created, it cannot be changed. That is what it guarantees that. Then first class, and it's a higher order function. Functions can be passed as an argument here, can be returned from the other function, and it can be assigned to the variables also. Maybe if you would have worked with any JavaScript library like React and all, so they make use of these things very extensive. Okay, and they're pure functions. They have no side effects and return the same output based on the same input. And most importantly, it is a declarative way of coding. Okay, it mainly focuses on the logic of computation without describing how it has been implemented. That is what happens in the imperative programming. Okay, but before we get into this, what exactly are how we going to implement these functional programming from Java 8 and all? First, let us see what were the limitations specific to the interfaces before Java 8. Okay, so let's see now. So before, for example, now earlier, that means before Java 8, I'll make use of an arrays class. It has a static method as list. Now I'm going to create these person objects. So person is a simple Pojo class. Okay, it has these fields. Okay, and constructor, parameterizer constructor, and getter and setter method. Okay, and I'm overriding the toString method. Clear? Now, I'll store this. Get this as arrays, not as list of objects with these objects. Okay, let me change this to 03 and 04. Okay. Now I want to perform sorting. How do we do that? So we'll make use of sort function. Collections is a class in the Java.util package. It takes an argument of my list, and I'll creating comparator. See what we are doing here is comparator is an interface. So we are making use of an anonymous class here. Okay. So through class without any name. Okay. So now it takes up a particular, that is person type, and I'll override the compare method. I'm going to compare these two objects. Now I'm going to compare with the first name of the first object and with the second name. With the first name of the second object. That is person one object and person. Then I'm going to compare. Okay. So we have to, even we want to implement the kind of implementation. Okay. Before Java 8 with the functional programming, functional interface and all. So we have to make use of, either I have to create a separate class which implements the comparator, or we have to make use of an anonymous class. Then I'll print all the persons list. Similarly, if I want to sort based on the last name, again I have to make use of the, so now I'll call get person last name on the first object, person object. Again, get person last name on the second person object. Okay. Similarly, for if I want to do performing sorting, then I have to address. Then based on the address, I have to do this. Okay. This is what we were making use of. So it is going to based on, for example, if you look at here, and I'm going to SOP of this first. Now it is checked. It is comparing with first person. That is name of the first person object. Second one. If it is not based on the, it's going to compare with the ASCII value here. Okay. Person first name, last name. Okay, like this. Similarly, PQRS R based on the last name I'm comparing here. I'm printing SOP of this. Okay. Similarly, based on the address. Okay. So this was the approach in before Java 8. Now, if I want to implement the same thing in Java 8 through functional programming and using lambda expressions, so simple. Okay. So look at here. Collections dot, again the same static method from the collection class. It takes list object. Okay. Now we are making use of this. This is what we as a lambda expression. Don't worry about that. We'll get into that lambda expression and all. I just want to show you to see the difference in writing a concise way of programming. No boilerplate of code. Okay. So then, based on the first name and we call compare with the first name and last name, it returns. Similarly for this. Similarly for this. Okay. Clear? So this is how we can achieve, instead of focusing on how to implement Okay, and defining different kind. I mean, each and every step, and changing, with the mutability of the data structure and all. So what we can do, we can make use of the function programming where it mainly focus on how, instead of using how, what we are supposed to do. Okay, that is why it uses the expressions, or through declaring the functions, passing function as an argument, and as well as using function as a statement. So this is what a big leap and changes to happen, which has been released from Java 8. Okay. Sorry, I'm sorry. Yeah. Clear. So coming back to this, even um, what were the limitations if you would have worked with Java interfaces? We have used created interfaces in before Java 8 and all. In interface, we're going to declare the methods. That means there is no method implementation or method definition, right? Now, what will happen over here? This limitation made it almost impossible to extend the existing interface or any other APIs, because that means when we have an interface, when I declare the method, now it is a responsibility of that class to provide implementation for that interface and its methods, because it's a contract between the class and that interface. So if I make any changes to any of that, if I want to add new, a business method or anything in, so even in the implementation class, it has to get changed, isn't it? Okay. But from Java 8, okay, we can you can create a functional interface, okay, and in that functional interface, you can also have a default method, okay. So here, before we get into this, so what is a lambda expression? It's an anonymous, lambda expression is nothing but anonymous expression or a function, and it is expressed as an instance of the functional interfaces. So whenever we use a functional interface, there'll be so we use lambda expression to make use of that functional interfaces. Okay. So why do we require these lambda expression, and how it helps in creating concise way of coding? It enables functional programming. Okay. It is readable and it is a concise. There is no boilerplate of code. We can easily remove all this through lambda expressions. So it is easy to use APIs and any other libraries. Okay, because these APIs is designed using the lambda expression. Okay. So this is what are the signature? How do we create a lambda expressions? Okay. Whenever we create a functional interfaces, okay, there are already some of the functional interface being provided by the Java 8 for runnable, callable, and comparator. So if you look at Java documentation before, you know, uh, see here, if I search for Java 7 documentation docs, okay, if you look at here, the comparator, okay, it is not a functional interface. We look at here, comparator, or runnable, anything that it is not a comparator interface. But if you look at the same Java 8 docs, Okay. Can you see here? It's a functional interface. Okay. Now, let us see how we can create a functional interface. Before that, we used to let us see how what is functional interface. When you are creating an interface, when you want to make this as a functional interface, it should have one and only one abstract method. Okay. So functional interface must have one and only one abstract method. You cannot have more than one abstract method in functional interfaces. So marking with this interface is optional, but it is always good coding practice to mark that interface with a @ functional interface. Okay, clear? Now, let's see here. My class earlier, before Java 7, we were, my class is implementing my interface. Okay, for example, I have an interface called my interface, and then we have a method m1, and my class is implementing this interface and overriding the method. Earlier, what we were doing, we were creating an object of the class which is implemented this interface, and we are invoking that method. This is what a common approach, or the approach which we were using till the introduction of Java 8's functional programming and Lambda expression. But using Lambda expression, we can simply make use of calling these functional interfaces using, this is what the Lambda expression. Okay, beginning with the parenthesis, and okay, I'll tell you why you require this. Okay, then hyphen and greater than symbol. Okay, this is for the expression, Lambda expression, and some statement, some expression I need to execute. Okay, so here in my interface, I have a functional interface. This is a functional interface, and it has an abstract method. Okay, now there is a class which implements this interface and overriding the method. Okay, clear? Now in regular way of calling that method, when the class is implementing that interface, we must create an object of that class. Okay, and we have to call this method m1. But now what I'm doing here, okay, with the help of Lambda signature, okay, with the expression, now I'll call system.out.println calling the method m1. Now we are assigning to what type it here is. We are assigning it to functional interface type. This is the important thing here, right? And from that I'll call. So it always calls the functional interface method. So this functional interface, it has a method m1. So using Lambda expression, okay, we're going to call, okay. So when we invoke m1, it always invokes the interface, that is functional interface method m1. So there is no boilerplate of code is required here. That is why it's called, with the help of Lambda expression and functional programming, we remove these additional code. Okay, clear? Like that, I have another functional interface called my calc, and there is a sum function. So what type of function it is? It is a public and abstract. Remember, functional interface, it can have only one abstract method. Okay, and it takes two parameters. Okay. Now in main class, so what I do, if you look at here, I'm passing with within the parenthesis int a comma int b. Okay, even if I take off this particular type, it is not, it won't give any compile or error window. Okay, to make you to understand. Okay, that is why I'm passing a is of int type and b is also of int type. So my expression, that is lambda expression. Now what it has to do, now I have a mathematical function. I want to perform this. That is adding these two parameters. So I'll assign it. That means I'm going to store it in the myCalc. What is myCalc here? MyCalc is a functional interface, right? Now I'm going to call calc.sum. I'll pass the argument. I'll store it in the result and it is going to result. So simple, no? So there is no any, I don't require any either anonymous, instead of explicitly creating an anonymous class for that particular interface, then invoking that method. So it's not required. That is the beauty of the functional programming with the lambda expressions. Okay. Am I clear? Okay. Yes. A functional interface in Java, as I said, it's an interface that can contain only one abstract method. Along with that, it can also have, default and a static methods. So what is this default method? These default methods provides a default implementation for a particular method in an interface. See, this feature was not there before Java 8, right? So if you create an interface and if that interface has, if you declare that method, only declaration part was there. There's no method definition. But in my design, in my application, I may require a certain method to be implemented in a default way. So that is why from Java 8, they introduced the default. We can make use of a default implement. We can define a method with a default implementation, and also we can create a static methods which are independent of any specific instance of that interface, right? So we already know what is a static members. Okay, that means irrespective, it does not belong to any object. It belongs to the class. Okay, without creating an object for that class, we can directly call the static method. Similarly, over here also, we can also have a static method. Okay, it can be directly with the itself. It can be called directly with the interface itself. So I said, this is how we're going to create an interface with the by annotating with the functional interface and all. This is what the syntax. So if it doesn't require any argument list, then we're going to open with empty parenthesis and close the parenthesis. This is the expression. Then hyphen angular greater than symbol. Then we'll be having an expression. Okay. Or in case if I want to have in one of the example in my functional interface, there is some method, it takes 2 arguments, right? Then I can specify the argument list. Then we'll be having statements. Okay. This is what we call argument. This is what we call as an array token. And this is what the expression are the statements. Okay. If you have a multiple statement, then we have to make use of these curly braces. Otherwise, if you have only one single statement, then the curly brace is not needed. Okay. So let's see a few examples with respect to the lambda expression. Okay. For example, I'm creating another functional interface called lambda. And it has a method declaration display. It takes an argument of integer and returns the integer type. Am I clear? Now, how do we use this? Okay, the lambda expression. First, it takes an argument. So I have required one argument type. So using parentheses is optional. Okay. Then my expression. Now I have a statement. So I have an expression here. Now return number into number. Okay. I'll store it in the lambda. Now I'll call lambda.display. I'll pass the 20. Okay, this is so simple. So whenever this code will be executed, whenever it comes, the display method is called using the lambda. Okay, whenever we call display method in the lambda, because display is a method in functional interface lambda, isn't it? Okay, like that, let us see how we can iterate without using like what we were doing in the imperative way of. So for iteration of all the elements which is being stored in any data structure. Okay, so now I create an array list object which is of string type. I'm going to add these are the items being stored in the grocery list. Okay, so using lambda expression, okay, this my list provides a method for each. Okay, so for each it takes a consumer. We'll come to see. We'll see what is a consumer and all. Okay, supplier, consumer and all. For each item, it has to print. It has to iterate and it has to print it. Okay, so there is no additional step for iterating with getting the total size of the a list and then iterate one by one and all. It's not required. There is no need of explicit what we call as with the help of a iterator interface and all. It's not required. Okay, so the list interface which has been created in the forEach method, which has been created in the list interface. Okay, they have added a function called, they've added a method called forEach, and it takes. So using my lambda expression, I can iterate with all these elements. Okay, look at here. So 20 to 2400. This is for the first one, and second, I've created array list object, adding these elements to my array list object, and using for each function of the list. Okay, using my lambda expression, a simple, a concise way of coding. Okay, for each item which is being stored in my array list, I want to print that. This is what we can do it. Okay, this is one way of using the lambda expression. Let's see. Okay, I want to show one default method and okay, using static method and default method. Okay, see for example, I have an interface I1. Okay, let me take another example. So what kind of method is this? It's a functional interface because I have only one abstract method, but can have default method and as well as static method, isn't it? So in my interface, okay, I can also specify with, it's always good practice to you annotate with functional interface. Okay, there's only one abstract method and also have default method, okay, and a static method. Okay, so for this, so not this. Okay, this is how we can okay. Now let's take one real-time example like I have a interface called vehicle. This vehicle, it has an abstract, public and abstract method start, and it has a default. So every vehicle should stop, but I don't know what type of vehicle, how it's going to start. Okay, so depending on the implementation of that particular vehicle type, I'll implement accordingly. So that is why there is a default way of stopping the vehicle. That is what I'll provide. So I'll use a keyword default, then stop method, and it doesn't have any return type, so I'm using what. Okay, now I'll create a particular class called car, which implements this functional interface. Okay, then I'll call start method. So now start method is going to call start. Now what will happen here? So when we create a car object, okay, now I can call start method and stop method, right? So this is how we can create and make use of both, creating a functional interface which is having both abstract method and as well as a default method. Okay. This is one way of using it. Now let me take one more example here. Yeah, how to make use of static method and yeah. Okay, is that I have chemistry. Okay, so I'm creating an interface called Kia vehicle. What type of interface? It's again in functional interface. I have abstract method, public and abstract method. Again, a start method with just empty block. There is no implementation. It's a default method. There is no any kind of logic, any kind of code implementation is not there, but it just having an empty block. Similarly, I have another method called static, because from Java 8, an interface can have abstract method, can have default method, and also can have static method. Now, there's a method called model, which takes an argument of string with the model number, and I'm printing what is the model number. Okay. Now, for this interface, I have two different implementation class. One is Kiosk on it, and another is Kiosk Seltos. Okay. Now, this I'm overriding the. So, what are it contains? Company details. This is my abstract method. So it is printing the name of the car. So again, overriding the start method and stop method. Similarly, in case of Kia Seltos, I'm overriding only the abstract method, because these methods, anyway, it has been available. Okay. After that, yeah. Okay. Now I'm going to create Kia vehicle object. That means I've created a Kia Sonnet. So what is Kia Sonnet? Kia Sonnet is one of the implementation class of this functional interface. Okay. I'll assign it to the reference variable of interface side. Now I can call company details, start and stop, and as well as the model, because say, please look at here. I'm calling this model method. I'm calling this static method using the name, okay, of the interface. First, how do we call the static method? Like by using the class name, right? Even from Java 8, when you're creating a static method in an interface, when you're defining a static method interface, you can call with the help of directly with the interface name. Okay. Now I'm calling the company details, and also I'm specifying the model here. Right. So in this first one, when I calling company details, Kia Sonnet, just printing the name of the car is Kia Sonnet, starting of the car and stopping the car. And what is the model? So now here, when I specify company, the model here is this. Similarly, for the second implementation class, that is for Kia Seltos, I'm overriding only one, that is abstract method, Kia company details. So, right, then we call the static method directly. But since this interface, that is the start and stop method, is already available to the class, so it is printing even that what is the name of the car, say Seltos, and what is the model. But since I've not called for the start and stop method, it is not printing for the key centers. So, using with the help of static method and default method, we can in the interface while designing our application, an interface need not to contain only the abstract method. When you're creating a functional interface, that functional interface along with one abstract method, it can also have a static and default methods. So default method is to provide a default implementation for that interface. A static method can be called directly with the interface name itself. Okay. So for example, I have static method cannot be overridden. Um, so keep in mind that. Okay. See, I have two static method in this interface math operation. One is add and another is multiplication. So how do we? Okay. So using static, since with the help of interface, I can directly call these static method. Okay. So like how we used to call the static variables or static method when we have in a class. Similarly, when you have a static method in the interface, you can directly call with the interface name. So add is a static method and also the multiplication. Okay. What is method references in Java 8? These method references is nothing but is a shorthand notation for the lambda expression that can be called on a single method. Okay, we'll see that. It can be used to simplify the code and make it more readable. Okay, there are different way of using the method references in Java 8. One is to call a static method. Okay, it can be used method reference to call the instance method to create an instance of any arbitrary object of a particular type, and also we can use reference to a constructor. Okay, so let's see an example on this. Let me close these code. Okay, let's see here now. I have a class called math-utils. It has a static method. Okay, this static method has it's taking two parameters and it is returning multiplication of these two. Okay. Now in the class, by using double scope, we can call math-utils. To use method reference, we use double scope. Okay. Then multiply. What is multiply here? Multiply is a static method in the math-util class. So there is no additional step is required. Okay. It always refers to a static method and we are assigning it to now in the Java.util function package, Java.util, and under that there is a package called function. There is a specific to particular data type, there is an int binary operator. Okay, I'm assigning it to because in the math-util it is taking an integer part as an argument as a parameter. It is returning that, and what return type is integer. So I can use I'm assigning to this. Now what I'll do operator dot apply as int. Okay, it provides a method apply as int. Okay, we look at here. See again, it's a functional interface. Look at here. Okay, there is a beauty of using these using lambda expression, functional interfaces, and all. Okay. Now I'll print the result here. Similarly, I have another class called person. It's a simple Java class with a name, and it has a constructor and getter method for that. Okay. How do we apply this method reference for the object for the instance type? Now I'll create a person object. Please look at here. By using the constructor and passing the name of the person. Now I want to invoke that one particular method like get name method. It's an instance method, no? Okay. Now I can apply this again, double scope operator. Okay. Person, double scope, get name. I don't have to specify get name with the parentheses and all. It's not needed. Now what type it is? Now it returns a particular type. That is what supplier. We'll see what is supplier and all little later. Okay, which is of string type. Now I'll call supplier. It provides a method get. It returns that type which we are passing this to this as an argument, and we are printing it. This is another, this way how we can make use of applying these methods. Okay. How do we pass a reference to the constructor, for example? Okay. For example, I have an employee class here. This employee class is having employee ID, employee name, and I'm initializing this two instance variables inside the constructor. Okay. And getter and setter method for this. How do we apply reference to a constructor method reference? So for this, so what we do, please look at here. Employee, double scope, operator, new, just new keyword. And we are making use of the by function here. By function is it takes based on the constructor of that particular class for the employee. Now it is of integer, string, and what type it is required. It is of employee type. See, earlier what we used to do before that, we used to create employee, okay, emp object equals new employee, and we have to pass the argument like employee ID 100 comma some name, right? This is what the regular way of object creation, isn't it? Now using the method reference, we are applying this for the instance for that employee, and we are assigning it to by function. What is by function here? That is one of the functional interface again. Okay. It takes two arguments and produces the result here. Okay. Based on what type of object instance you want to create. Now in my employee class, it takes argument of first is integer type, another is string type. Okay. Now I'll call employee constructor dot. This employee constructor, this by function provides a function apply. I'll pass the value and I'll get in this. So this is how we can make use of the method reference. Okay. So whenever this is a shorthand way of applying this expression for the lambda expression by using this shorthand way of calling the method or calling the static method, or applying this to the for the any instance method or for the constructor. This is how we're going to do it. Okay. So we have used static. Now the next important thing is, most important, we go make use of the stream API, Java stream. So in Java stream, what exactly a Java stream is? Okay. It's a sequence of elements that can be processed in a functional style using operations like filter, map, and reduce. Okay. So a stream is different from the collection in that it does not store element itself, but rather it provides a way to access these elements from the source. Like it could be of a collection or it could be from any input and output. Okay. So a stream is different from a regular collection. It does not store any element of its own, but it provides a way to access or way to process these elements, which is from either from a collection type or from any file. Okay, when you're performing through IO. So what about the limitation? Why we have to use the stream API? So limitation with before Java 8 collection is We required the processing of collections for these list, maps, set, and all. We were making the imperative way of coding. That is what I had told you showed you in the exam in the earlier in the beginning. Like when I have an array list object, when we want to store the elements and when we want to iterate, when we want to process these and all, we have to require additional coding. Okay, but by using the Stream API, we don't require these imperative way of coding at all. Okay, these approach had a lot of drawbacks. What is that? Verbosity, writing multiple loops and conditional to perform operations like filtering, mapping, reducing. Again, it is repetitive. Okay, based on different scenario, we may require to filter our objects. For example, I want to filter the employees based on different conditions. I want to filter the employees whose salary is greater than 5,000. I want to filter the employees based on the location. I want to apply filtering for based on the different conditions. So we have to repeat this. So readability of the code requires a lot of loop, multiple steps, making code harder to read and maintaining. Inefficient parallelism. What is this parallel processing? This is one more important feature in along with the functional programming in Java. Right? Parallel processing, it involves uh, dividing your task into a subtask, smaller task that can be processed simultaneously across multiple processors. Okay, so what is the advantage of this parallel processing? It reduces the time required to perform large-scale operation or large-scale computation. Okay, so that it can completely make use of the complete utilization of your processor. That is what parallel processing. It is one more important feature from Java 8. So maybe in the upcoming webinars and all, we'll be discussing on these with parallel processing and all. Okay. Anyway, so declarative. It is what are the benefit with using Stream API? One is declarative data processing. It allows developer to express what they want to achieve without specifying how it has to be implemented through using additional steps like iterating with conditional statements and nothing. We just need to what I want. That's it. So with the help of this declarative way of approach, so maintaining readability, code readability, and maintaining the code becomes very easy. Okay. So it is a conciseness, less boiler. What do you mean by conciseness or concise way of coding? Mean it less boilerplate of code or repetitive code. That's it. Okay. See, for example, here I have a list object. This list object. So I'm creating an arrays as list. These are stored in a list object. If I want to achieve in an imperative way of storing to filter all based on the even numbers. So what I have to do again, I have to make use of a for loop. Then I record a for loop. Then you have a condition inside the for loop. I have to have a if conditional statement. Then perform this and get these even numbers. But with the help of declarative approach, we don't need because we're going to make use of a stream function. Okay, on the list which holds these elements. Now there is a pipeline. It's a chain of function method calling. Okay, filter. Again, my lambda expression comes to play here. Okay, modulus of t if it is equal to 0, then for each of this, what do you call this? Again, method reference. For the println function, I'm applying this method reference. So simple. We'll see an example of this. Internal iteration. Okay. Optimize the performance. So what do you mean by this is very important. They might ask you why Stream API is very important. I mean, is being introduced from Java 8. What is this lazy evaluation? Operation on these streams will not be executed until the terminal operation is invoked. Okay. So there are two things basically in the stream: intermediate operation and terminal operation. What does it mean intermediate operation? These are operations or the methods that transform the stream into another stream. Okay. So these methods or these operations are typically like filtering, mapping, or transforming the elements and all we do it. Then what is this terminal operation? This terminal operation, it produces the result. It just returns that other side of it. That's it. Okay. So with the help of lazy evaluation, okay, until it is required, okay, it won't be called. It won't be, these operations will not be called. So this can lead to performance optimization. Okay, lazy evaluation. Similarly, optimize the performance. It can optimize the processing pipeline, potentially improving the performance without writing any manual coding intervention and like additional additional code is does not required over here. Okay, so that is what I told you, enhance parallelism and concurrency and all. Okay, fine. Let's see an example on this. What happens now. So I have an array or a collection or IO from the IO channel. So we have a stream source. Okay, we are going to call stream function on that. So we perform certain filtering or mapping or reducing. So these are all intermediate operation. Once it has been done, okay, now it goes to the terminal operation. Like I want to collect all these after filtering. I want to collect all these elements or the data, and I want to give it back to the result. Okay, so this is how it is going to work. So these are the, please remember, streams are not data structures, but tools for performing operations like map reduce transformation or the collection. So it is, don't think stream is it's like a data structure. No, it is a way of processing to perform the operations like filtering, mapping, reducing, all these things. Okay. So it provides a concise and expressive way to process the collection of the data. Okay. So whenever we apply the streaming, we always make use of the functional programming approach or paradigm. Okay. So let's see now example on this. For example, now I have an employee class. I have first name, last name, and salary. Now I have a list of projects for that employee. Now it's of string type. Then I have a constructor, then getter and setter method. Okay, clear? Now, please look at here. I'm creating a static. I'm creating a array list object. Okay, with a list of employee. I have a static block. Now I'm going to call employee.add new employee, and these are the employee details. Okay, name of the employee, first name and last name, salary, and this employee has a list of projects, right? That is why I'm calling list of. List is a interface. It has a function of project 1 and project 2. Similarly, another employee, salary, list of project 1, project 3, like this. So in the main method, so I'll simply make use of. Now, how do we use stream API? So first we have to use stream method on that collection. Okay. Then what I want to perform, I want to call forEach. Okay. So that I want to get all the employees. Okay. Now for that, we'll make use of the lambda expression. For each employee, I want to retrieve all the employee. And I want to print it to the console. So that is what we are doing here. Okay. Similarly, I want to perform mapping here. Again, I'll use based on that. I have a set of, I'm creating employees. Okay. Again, I'll use stream. This is one way of defining or accessing the stream. Okay. I'll assign it to the set. Okay. Now I'll call. See, we can have pipeline here. One is after that dot map. Again, using the lambda expression, I'll create an employee object. Okay. I'll get the current employee, first name, last name, and salary, and incrementing the salary. I'm increasing the salary for all the employees, and also I'm accessing the projects. Now I'm going to call collect. Collectors is a class in java.util.Stream package. It provides to set. If you want to get it back as a list, it provides a method to list like this. Okay, clear? So this is how. Now here also we are comparing with. First I'm filtering. Now we are providing a map here. Now I'm filtering. Based on the employee's salary greater than 7,000. Okay, I want to filter that. Then I have to map. Okay, by accessing that employee. Then find the first, or else return the null object. Here we are storing it directly with the employee object. So I'm applying employee.stream. Okay, employees.stream here for the collection employees.stream and assigning it to the employee object. Now I'm performing two things here. So intermediate operation and as well as terminal operation here. So first here I'm applying the intermediate operation with whose salary is greater than 7,000. Then map all those employees. I want to find the first employee. In case if it does not, it returns only the null object. Okay. So let's see now. Okay. So let me 4,000. Okay. Now we just bring employee. The salary is this. I'm giving change the condition. So this is how we can make use of the Stream API. Okay. Now there are different approaches where we can make use of the creating the stream method here. So one is there's an empty stream. I can creating an empty stream object. Okay, creating an empty stream. Stream is a class which has an empty static method. Okay, now when I try to access that using forEach, it won't print anything because it's an empty stream. Now what I'm doing here is I'm creating a list object. I'm adding these string to my list. Okay, this is clear. Now I'll call create an object of this class. Now I'll call demo dot. Stream of is a user-defined function, user-defined method. It takes an argument of list. Okay. Now it is going to return again the stream object itself. But have a condition. I mean, it is returning. If it is going to check if it is equal to null or it is empty, then call this stream.empty. Otherwise, this dot stream. Then call stream function on this. So these are different way of creating a stream. Okay, by using a stream. One method is stream. Okay. Next, for example, I have a student class. You know, do we have how much time? How much time you left? Hello? Hello? Okay. Oh, okay, fine. I think it's so we have to, since there are a lot of examples, I need to show for each and every implementation the concept. So that is maybe it is taking um, more time. Anyway, so hopefully we'll in the next upcoming session we're going to cover up whatever left out is, because we have optional, then making use of the time okay API and all. Okay, so in the next upcoming session we'll be working with other features from Java 8 and as well as with Java 9 to 17. Some more important features been introduced from Java 9 to 17. Okay. Okay. So hello. Yeah. So thank you so much. We'll catch up soon. We'll be continuing with making use of implementation of the other things, optional, and some more real-time examples, and some more other features starting from Java 9 to 17. So thank you so much for your time. Happy learning and happy coding. Thank you.